Hey guys, what's up? We're going to look at resistors in series and we're going to learn how to derive the total resistance of a number of resistors in series. So here I've got two circuits which are actually equivalent to each other. On the left I've got three resistors, R1, R2 and R3, and they're all in series. They're connected to an EMF supply which has got a voltage of V, and the current is the same at all points is given by I. We can simplify this circuit to combine all the resistors to give us a total resistance RT. It's still got the same EMF and we've got the same current. And we want to know what is RT in terms of R1, R2 and R3. So looking at circuit B, we can use Ohm's law. V is equal to IR. Therefore, the total resistance RT is equal to V divided by I. If we have a look at circuit A, on the left hand side, we're now going to use Kirchhoff's second law, which is that the sum of the EMFs is equal to the sum of the potential differences in a loop. The EMF in this circuit is capital V, and we've got a number of potential differences. We've got V1 across R1, V2 across R2, and V3 across R3. So we can say that the EMF V is equal to V1 plus V2 plus V3. And we know from Ohm's law that V is equal to IR. So we can say that V is equal to IR1 plus IR2 plus IR3. I'm now just going to factorize this, which gives me V is equal to I brackets R1 plus R2 plus R3. Now if I divide both sides by I get V over I is equal to R1 plus R2 plus R3. And if we look at both of these equations that we've got, the first one, V over I is equal to RT, and we've got V over I here. So we can make these two equal to each other. So we can say that RT is simply equal to R1 plus R2 plus R3. We could have repeated this process for any number of resistors in series. So it's important to note that the general formula is RT is equal to R1 plus R2, and you just keep repeating and adding the number of resistors that you have in series with each other. And there we have it, that's the derivation. So let's look at how we can use this to solve some problems. So the first one, we've got two resistors, 125 ohms and 250 ohms, and we want to calculate the total resistance. We simply do RT is equal to R1 plus R2. Therefore it's 125 plus 250, which gives 375 ohms total resistance. The next one, we've got three resistors, 700 ohms, 2.5 kilo ohms, and 1400. So this time we do RT is equal to R1 plus R2 plus R3. You just keep repeating for the numbers of resistors that you have. That's 700 plus 2500 because it's kilo ohms plus 1400, which gives me 4,600 ohms. Finally, we've got 10 resistors that are each identical, 120 ohms each. We've got R1 is 120, R2 is 120, and all the way up to 10 resistors, each of 120 ohms. So we could write RT is equal to R1 plus R2, and we go all the way up to plus R10. But I can simplify that and just say it's 10 times R1 because they're all identical, which is 10 times 120, which is 1,200 ohms. So it's really easy, and all you've got to remember is that RT is equal to R1 plus R2 and so on. You just keep adding the resistances together. So in summary, what you need to know for your exams, you need to know the derivation, which uses these two circuits here, A and B. And all we used was Ohm's law, and we used Kirchhoff's second law, which is that the sum of the EMFs is equal to the sum of PDs. And then we simplified this down and we got our expression. RT is equal to R1 plus R2 plus R3. You just keep adding the resistors in series together. That's it. Thanks for listening. See you all soon.